if you've practiced and hopefully memorized your multiplication tables, you'll now find out that you're prepared to do most any multiplication problem. You just have to understand, I guess for lack of a better word, the system of how to do it. But we're not just going to teach you the system. We're going to show you why it works. So let's start with a multiplication problem that you probably think that you don't know how to do. Let's do 16 times 9. 16 times 9. You immediately might say, Sal, I haven't memorized my 16 times tables. There's no way I'm going to be able to do that problem. And my answer to you is you can absolutely do it, because we can break it down into problems that you do know the answer to. The way you do this one is first multiply 9 times the ones place here. So you multiply 9 times 6. And I think you know what 9 times 6 is. I'll write it down here. So 9 times 6 is 54. You know that from your multiplication tables. And so what you do is you write 54, but you only write the 4 down here in the ones place, and you carry the 5. Or, well, yeah, that's exactly what you're doing. We also use the word carry when you add and you kind of have an extra 5 to deal with. But let's just call that carrying for lack of better words as well. Now, we multiply 9 times 1. 9 times 1. Well, that's straightforward. 9 times 1 is equal to 9. Anything times 1 is equal to 9. But we have this 5 sitting up here. So 9 times 1, we have to add that 5. So we have to add that plus 5. So plus 5. And so what do we get? So 9 times 1 plus 5 is 9 plus 5, which is 14. 14. Let me write it right there. 14. And there you have it. 16 times 9 is 144. And if you remembered your times tables up to 12, you'll also realize that's 12 times 12. But just knowing only these two pieces of information, we were able to solve a harder problem. Now you might say, OK, Sal, that's a neat little trick you just did. But how does it work? And you should always ask that. You shouldn't just take it, you shouldn't just memorize the system and assume that it works. And to explain that, I'm just going to rewrite these numbers. I can rewrite 16 as 10. Let me do it right here. 10 plus 6, right? This is 16. And I can rewrite 9. Well, I'm just going to write 9 as 9 right there. And now let me do the multiplication problem. I'll put a little multiplication sign out there. So first I want to multiply the 9 times the 6. And you might say, hey, Sal, why did you divide it this way? Well, I wanted to separate the ones place from the tens place. Right? This 1 here that's in the second column, it isn't a 1, it's a 10. It's a 10 plus a 6. So that's why I wanted to write it that way. But anyway, let's do this problem. So we do it the exact same way we did it before. We say 9 times 6. So let me write that down. 9 times 6 is equal to 54. But instead of writing 54, I'm going to write that's equal to 50 plus 4. Right? 9 times 6 is equal to 50 plus 4. Well, this is my ones column right here. Let me make a little dotted line. This is my ones column. So I can only put a 4 down here. But I need something to do with the 50. I have to put it someplace. And just the convention, or at least the way that I've learned it, you put the 50 up here. I could have put the 50 down here too, as long as we remember that this 50 now goes into this column. So you can stick the 50 over here. That's what we did in the first video. I just wrote a 5. In that first video, I just put a 5 here because I was in the tens place. A 5 here really means 50. A 1 here really means 10. But now I'm writing it out so you can see that they really mean 50 and 10. And then you say, what's 9 times 10? 9 times 10. 9 times 10. I say, hey, Sal, well, you've memorized this. And anything times 10 is just that anything with a 0. So it's 90. So it's 9 times 10 is 90. And then we want to add 50 to it. So we want to add 50 to it. What's 90 plus 50? It is 140. So 9 times 10 is 90, plus 50 is 140. And we could rewrite 140 as 100 plus 40, just to be consistent. So what we'll do is we'll put the 40 down here. We'll put the 40 down here. And then we carry the 100, but the 100 really doesn't go anywhere. I mean, we could write it up here. We could put it well, we could write the 100 over here. We could put it over here. There's a bunch of different places we could put the 100. But the important thing is it sticks out into this next column that I haven't drawn yet. So then you'll put 100 here. So our answer is 100 plus 40 plus 4, which is 144. Hopefully you found that reasonably explanatory. Let's try a couple of other problems, because I think it's all about seeing examples. So let's try 55 times 8. 55 times 8. Same exercise. First you start with the 8. 8 times 5. Let me write it down. 8 times 5 we know is 40. So 8 times 5, you write the 0 down here. It's 0 plus 40. And then you say 8 times 5 again. That's 40. But then you add the 4 to here. So you get 44. So it's 440. And you could try to do it the same way I did that last one, where I broke it out into 50 plus 5 and then an 8. But I think the more examples you'll see, this will all become a bit of second nature to you. So let me do another one in this. No, let me do it in this salmon, this light red, this salmon color. So let's say I had 78. 78 times, let's do it times 7. 8 times 7. 8 times 7 is 56. Let me write that. This is a different problem now. So 8 times 7 is equal to 56. We write the 6 down here, put the 5 up there. 7 times 7 is 49. 7 times 7 is equal to 49. But we have to add this 5 up here. So you add this 5. What's 49 plus 5? Well, that's 54. So 7 times 7 is 49, plus 5 is 54. 546. You probably, 10 minutes ago, you probably never thought that you could figure out, the 78 multiplication tables. But you see, it's a pretty straightforward process. Let's do a bunch more. I'm just going to do these until we all just collapse from multiplication fatigue. Let's try out let's do 89 times, let's do it times 3. What's 3 times 9? 3 times 9 is equal to 27. Put 7 in the ones place. Put the 2 up here in the tens place, because it's 20 plus 7. 2 tens is 20, plus 7 is 27. And then 3 times 8 is 24. 3 times 8 is equal to 24. But I have this 2 sitting up here, so I'm going to have to add 2. So I get 26. 3 times 8 is 24, plus 2 is 26. 267. Now, I'm going to do another one, but I'm going to up the stakes a little bit. I'm going to up the stakes. Just when you thought you were getting comfortable with this, I'm going to make you uncomfortable. Let's do 239 times, times 6. I thought this was a video about 2-digit multiplication times a 1-digit. Well, it is, but I just want to show you that you can really do any number of digits times this 1 digit, and it's really the same process. You could probably guess how we're going to do it. So what's 6 times 9? Let me write it here. 6 times 9. We saw this show before. This is 54. So you put the 4 down here, put the 5 in the tens place, because the 50 and 54 is really 5 tens. Fair enough. Now we're going to do 6 times 3. So 6 times 3, that's equal to 18. But we still have that 5 hanging out there, so we have to add that 5 up there. And we get, what's 18 plus 5? So 6 times 3 is 18, plus 5 is 23. So we put, but this is, just to be clear, we didn't multiply 6 times 3 and add 5. We actually, if you look at where we are in our place on the problem, this is actually a 30. I just happen to do a 3 here, but this is 6 times 30 plus 50, because 39 is 3 tens, or 30, right? So this number, it actually, even though we said 6 times 3 is 18 plus 5 is 23, this number is really 230. So we put the 3 in the tens place. Actually, let me do it in a different color than what I did up here. So this is equal to 23. We can put the 3 in the tens place, and then put this 2 up here. Now we're almost done. One multiplication left. Let's do the 6 times the 2. 6 times 2, that's an easy one. That's 12. But I have this other 2 hanging out up here. So I have to add this other 2. So plus 2. And what is that equal to? That is equal to 12 plus 2 is equal to 14. So I write the 4. So 6 times 2 is 12, plus 2 is 14. I write the 4 down here. If there was any more digits, I would write the 1 up there. But there aren't any more digits, so I write the 1 over here. So 239 times 6 is 1,434. Let's do another one. Let's do another one. I need to get some space cleaned out. And hey, while we're escalating the situation, let's go to 4 digits. Let's go to 4 digits. Let's do 7,362 times, let's do a hard one, times 9. So what's 9 times 2? And I won't do this side math over here. I think you're getting the pattern. What's 9 times 2? 9 times 2 is 18. 18. Then we do 9 times 6. 9 times 6 is 54. Then 54 plus 1 is 55. 55. What's 9 times 3? 9 times 3 is 27. Hopefully you have that memorized. And then 27 plus 5. 27 plus 5 is 32. Let me switch colors. Is 32. And then you have 9 times 7. That's 63. But we have this 3 hanging out there. So that's 9 times 7 is 63. Plus 3 is 66. You write the 6 here. And then you have nowhere to put the 60 in the 66. So you write that down here as well. And so 7,362 times 9 is 66,258. Hopefully you found that useful.